All right, so hopefully you've had time to look at these at problems 4, 5, and 6. So number 4 looks like it's just a normal x. All right, so if there's just a normal x happening, then that is going to be linear. When on number 5, if you look and see x is in the power or the exponent, so that should give you a hint that this is going to be an exponential equation. And then number 6, if you notice, we have this x minus 5 to the second power, so the highest power is 2, and that is going to tell us, hey, that's going to be a quadratic equation, and when we graph it, it's going to make that U-shaped parabola. All right, so we've looked at the first 6 examples. Now let's look at the next few here. So number 7, we have a diver. He jumps from a diving board that is 10 feet high with an initial upward velocity 4 feet per second. So here's our diving board, right? He goes and falls down into the water. So what type of function is that going to be? Hopefully you all were thinking quadratic, right? Similar to something being launched into the air, jumps into the air, makes that U-shaped graph. Alrighty, number 8. Looks like it's not a line, it's not a parabola. It looks very much like an exponential curve to me. So, right, we're approaching this, never going to touch or cross. Then it goes upward, so that's exponential. I'll just abbreviate. And then number 9, let's see what's happening to the y values with this table. Let's see. Negative 20 to negative 12, well, that's plus 8. Negative 12 to negative 4, that's another plus 8. Looks like it's going to be linear because we're adding the same value each time. Gotta stick to my colors here, so linear. All right. Now this next part, we're almost done. Hang in there. This next part, we're going to look at each scenario, decide, we're still looking at which one is it? Is it linear, quadratic, or exponential? And then we're going to write the equation. Now I only want you to write the equation right now for just linear and exponential. I haven't taught you how to write the equation of a quadratic quite yet, so we're just going to write those equations today. So if you look at number 10, looks like a beautiful straight line, right? So we have linear. We know it's linear. And then to write an equation of a line, well, looks like we need to know what's the y-intercept. So the y-intercept where it crosses right there is at 0, 1. All right, so our b value is going to be 1. And then we need to find the amount, the rate of change, or the slope. So I'm going to find another point on the graph, and I'm going to figure out, okay, we rise 2, and we run 1. And it has a positive slope here. So our slope is going to be 2 over 1, or just 2. So the equation of our line, remember we're using y equals mx plus b, is going to be 2x plus 1. All right, number 11, another table. So 2/3 to 2, 2 to 6, 6 to 18. Ooh, this definitely looks like it's multiplying by something. So, oh, what the heck? Sorry about that. So 2/3 times what is 2? Well, that's going to be times 3, I believe. 2 times 3 is 6, times 3. All right, so that's telling us it's going to be exponential. Oh, So we know it's exponential. And now we just need to find, okay, the a value, remember, is our y-intercept or our initial amount. So right here, our a value is 6. And then whatever this we're multiplying by, that common factor, is our b value. Sorry, my 6 looks like a b. Our b value, which is 3. So then our equation, remember, it's a times b to the x power. So I'm going to go 6, which is our a, times our b, which is 3, to the x power. Alrighty, so we're looking at number 12. We have a submarine. It's going on an expedition. It begins at 100 feet below sea level, and then it descends 25 feet each minute. So I see this keyword, each, right? Descends. So it's going down, descending down each minute. So that's going to be linear. So it begins at 100 feet below, going down. So it's definitely a linear problem. All right, and now we got to figure out, okay, if it started 100 feet below sea level, then our y-intercept or b value is negative 100 because it's 100 feet below. And then our slope, how much it's going down each minute, is 25 feet. So it's going down, which means it's going to be negative 25. So then when we write the equation of our line, it'll be y equals negative 25x minus 100. So start at 100 feet below, goes down every 25 feet. Alrighty, folks, we are on the last two problems. Okay, so not this number 13. So Efren has a 40-gram sample of an isotope that has a half-life of 3 days. So every 3 days, half of it dies, essentially. All right. So it starts at 40 grams, and then it takes half of it every 3 days. So half-life, I believe that was a key word for exponential, right? This half-life. So we know it's going to be exponential. So then for our exponential equation, we need to know, all right, what was the starting amount of this isotope? Well, it started at 40 grams, had 40 grams. And then our B, our growth factor, is, what is being multiplied each time? Well, it's being multiplied by half because it's going down, dividing by 2. So our growth factor is 1/2. So then our equation of this exponential is y equals, we put our a value first, so 40 times the growth factor or decay factor here of 1/2, and then to the x power. And the last problem, certainly not the least problem, is a beautiful parabola. There's a parabola. So it's definitely quadratic. And like I said earlier, you don't need to write the equation for this one because I haven't taught you that yet. That'll be in the future. So you just identify if it's quadratic for those. So we have gone over all the different formats to see linear, quadratic, and exponential, and some examples. So I hope that helps you with your practice assignment. Thanks for tuning in. Alrighty, folks. Last time we met, we reviewed linear and exponential problems and functions. And today we are going to continue to talk about linear and exponential, but we're going to add a new function type, which is called a quadratic. So make sure that you title your notes page on page 24, that we're section 1.2. And when we first talk about linear, quadratic, and exponential, let's look at the equation format first. So the parent function of a linear is just y equals x. So if you graphed y equals x, it would just be a straight line. Therefore, it would be a linear equation. And we also mentioned last time that the more common form that we're used to seeing is y equals mx plus b. So when you're looking at different types of equations, what we want to look for to identify a linear one is just a regular x. That's what we're looking for. So just a regular x that's maybe multiplying a number, fraction, but it's just regular x. Now let's look at the exponential. I'm going to skip the quadratic for just a second because that's the new one. But exponential, just the parent function, like the original parent function, could be like 2 to the x power. And then last time we also mentioned, well, we have this a value, which is the initial amount, times the growth factor to the x power. I'm going to cross that off because that's... So we talked about this last time, right? The initial value, and then however much it's growing by is the b. And what we want to look for is x is in the exponent. So when we look at an equation, what makes it an exponential is the variable is in the exponent or in the power. And then the new one that we're going to start learning a lot more about in the future is a quadratic. And the parent function of a quadratic is just y equals x squared. All right, and there are two main ways to write one. So we are going to fill in these two types first, but we're not going to focus on writing the equation of a quadratic until our next unit. So, but I'm going to write these here for the notes. It's ax squared plus bx plus c is the standard form. And then we'll also learn about this next form, which is x minus h squared plus k. That's vertex form, but we'll learn more about that in the future. But when you're looking at equations, we want to look for an exponent of 2. So when there's an exponent of 2, then we know it's going to be a quadratic function if 2 is the highest power. All right, so those are just the different equation formats that they're in. And now we're going to look at, okay, well, what does it look like when you actually graph? So for a line, obviously, it's going to be a straight line. And this can be a vertical line, or it can be sloped, right? Or horizontal, but it's just a straight line. Which we're used to that one, so that should be familiar. And then the other one that I did linear in green. Shame on me. This is green. I got to stick to my colors. Anyway, Now we got a Christmas theme going on. Okay, I'm going to skip to the exponential one, which is on the far right. So exponential graph, right? We have this curve that gets really close to a horizontal line, which is called the asymptote. So it gets really close and then it curves up. It may curve up or it may curve downward. All right, so we are used to seeing lines and we've seen exponential curves. So now a quadratic. When you graph a quadratic, it is this U-shaped graph. So it may be downward U like this, or it can be flipped and be an upward U. But this graph, instead of just U-shaped, it actually has a name. It's called a parabola. So this U-shaped graph, if it makes a parabola, then we know it's a quadratic function or a quadratic type of pattern. Okay, so we've talked about the different equation forms that we may see it in. We've talked about what the graphs look like. Now we're going to look at the tables, all right? So if you see a problem with a table for linear, right, to determine if a table is linear, it must have a constant rate of change. Or slope. That's another word for slope, right? What is this change that's happening from each y value to the next? And last time we talked about if we add or subtract the same number, it's going to be a linear model. So let's see what's happening here. From 2 to 5, adding 3, 5 to 8, adding 3. So if you noticed a pattern here, we're adding 3 to each y value. So that means the rate of change or the slope is going to be the 3, right? So m would be 3 in the equation of that line. Now let's jump over to exponential. We're going to do our review ones first, okay? So determine if a table is exponential. All right, the y values will have a common factor. This is when we multiply or divide by this common value. So I'm going to look at the y values. So 0.25 to 0.5. I also like fractions. So 1/4 to 1/2. What is it being multiplied by? Or 1/2 to 1. Or 1 to 2. So looks like here we're multiplying by 2 each time. Multiplying by 2, right? So we know that's for sure going to be exponential. And if we had to write an equation for this, we know the growth factor, or our b, is going to be 2. All righty, now we're at the middle one, the new one, the quadratic. Okay, so make sure you're listening here. When we look at a table of a quadratic, the y values will have this constant, which means it's going to be the same second difference. All right, and in the parentheses, these blanks here, we're going to write difference of differences. So what the heck does that mean? Well, let's first look at what's happening in the first difference, right? So our x values are just going up by 1, so that's good. Now we want to check what's happening from this y value to this one. So to go from 5 to 2, well, that's subtracting 3, so that's a minus 3. To go from 2 to 1, that's a subtract 1. All right, so it's not linear because these aren't the same numbers, but let's go from 1 to 2. we added 1 to go from 1 to 2. And then to go from 2 to 5, we are adding 3. So notice the first difference between the numbers, they're not the same number. So I'm going to look at the second difference. So that means, well, what's the difference? How do we get from -3 to -1? Well, we can add 2 to get from -3 to -1. And then to go from -1 to a +1, wait, that's add 2 as well. And then to go from 1 to 3, that is also adding 2. So notice how these are the same value because it's the second difference of the y values. And that constant number means they're all going to be the same. So if that second difference is the same, then that's what makes it a quadratic function. All right, and that second difference comes from the x squared in the equation, but we'll learn more about that in the future. So check the tables and see what's happening. And then now we're going to look at word problems. All right. So linear word problems, we talked about this last time. They contain a situation that has an additive property. You know, this can be both add or subtract. Okay. And we want to look for these words that indicate slope. And some of these are the word each or every. That could indicate something being added or subtracted. And per. You know, if something is per month or per day or anything like that. So this example with Raphael has 25 seashells, and then he collects 5 more every trip, beach trip. Okay, so he starts out with 25. All right, well, that tells me that's going to be the initial value or our y-intercept. And then each time he goes, he collects 5 more. So that means we are adding 5, right? That's going to be our slope. Is that plus 5 each time? All right, now we're going to go over to our exponential, the ones we're used to. Okay, when we look at word problems with exponential, we're looking for this multiplicative property. All right, say that 5 times fast, right? Okay, so this multiplicative property means we can be multiplying or dividing. Okay, can be either one. We're going to look for percents, all right, whether it's a percent of increase, decrease, or other words that mean multiply are double, triple, right? Doubles times 2, triple would be times 3. Or the other one that indicates exponential is if it mentions like a half-life. So if anything has a half-life, that means it's going down half each time. So the example here is, okay, if a population of a certain town is expected to double, well, if it's expected to double, that's our secret word, then that means it's going to be represented by an exponential function because it's going to be doubling each year, however often. Okay, now we're going to look at our new one, the quadratic word problems. Now these happen all the time, all right? These are word problems that involve something being projected in the air, so thrown in the air, launched, whatever it may be. Or they also sometimes involve problems with area, all right? Because area is units squared, so that's where the x squared comes from. Anyhow, so the example here with a quadratic is, okay, if a soccer ball is kicked into the air from the ground. So if we were to graph that, if a soccer ball starts on the ground, it kicks upward, and it falls back down. right? So this would be the path of the soccer ball, and that, folks, is a parabola shape. So that is going to be a quadratic. So anything involving, anything being thrown in the air or falling from the air, anything like that will be quadratic. Okay, so we have mentioned the different types of equations, what the graphs look like, what the tables can look like, and different word problems. So now on your next paper or page, we have examples. Okay, so for each of these, we're going to decide which representation it is. Is it linear, is it quadratic, or is it exponential? All right, so this number one is a graph. And hopefully you look at it and you see a parabola, right? This is definitely a U-shaped graph. It is a parabola, so it's definitely going to be quadratic. Okay, for this number two example, we're looking at a table. All right, so we want to look at, well, what are the differences? What's happening to get from one y value to the next y value? Well, let's see, -9 to -4, that's adding 5, right? -4 to -3, that's adding 7. So it's not linear, it's not exponential, so we're going to hope it's quadratic, but let's check it out. So from 3 to 12, it's +9, and from 12 to 23 is +11. So remember, as we talked about here with the tables, a quadratic, we want to make sure the second difference is the same number. So if we found the second difference of these, so 5 to 7, oh, there's a +2. 7 to 9, +2. Okay, well, that tells us that the second difference is the same, right? So that is going to be quadratic. Okay, example 3, we have Juan just got hired at a job. All right, they're offering him an annual salary of $65,000 with a 3% increase. Oh, my pen. 3% increase in salary each year. Okay, so 3%. Which function type involves increasing by percent? Right? So that's going to be our exponential type. Our exponential problems increase by a percentage. And just like we talked about last time, if it's increasing by 3% each time, then our B value, which is our growth factor, is going to be 1.03 because it's growing more. So that's why we have the 1 in front of it. So this is exponential. Okay, I am going to pause for a little bit. I'm going to give you guys a head start on the equations. So on these 4, 5, and 6 problems right here, I'll give you a head start to try to figure out if it's linear, quadratic, or exponential.